Anyway, I would like to thank again Professor Toyota for inviting me, and also Faculty of Sciences to give me the opportunity to be with you guys here. And today is my last day of staying here. In my last lecture, I heard that probably I was speaking a little fast, so I tried to be as slow as possible. And keep in mind that when I become too much involved into my topic and my subject, automatically my voice becomes faster and faster and faster, and nobody can follow. So please, if you cannot follow, raise your hand. I will slow down. No offense. Don't worry. I will not be unhappy with this. Would you please just turn off the light in the screen? So today, what I'm going to do is just to talk about my recent activities in the cancer area, because my major is design and development of molecules which can affect cancer. And I'll be talking at the beginning about the nature of cancer, what is it, and also different types of cancer, treatment of cancer, and the targeting cancer. Then getting to the molecules that was recently prepared for treatment of cancer. Of course, one thing that before I get, I didn't have this one in mind till now. I thought it is better to let you, students know about this situation, that each medicinal chemist has different type of approach when they want to design new molecules. My approach in designing any molecule is designing something which is very effective and is less toxic to the body. So that is one thing. Usually cancer molecules which are used for the treatment of cancer, because the biology of cancer cell is very similar to biology of normal cell, except one case, that cancer cell replicates fast and doesn't die while normal cell dies. That is the differences between these two. So because of this similarity, resemblance, when you make a drug which can affect cancer cell line, means can kill cancer cell line, you have to expect that that molecule will also affect your normal cell line. That is a reason most of the anti-cancer drugs are toxic, cause different type of toxicity in human. So my strategy is to make a molecule which can kill cancer cell line but does not affect, or even if it affects normal cell line, usually it should be least effect on the cell line. So cell line can survive. So human can simply easily be able to take a molecule without any problem. So now I'll just move on to first section. Before you talk about, this is again my approach, before I talk about any disease and any drugs which are affecting that disease, I'll just come up with the statistics about the disease. This statistic that I'll show you now is just published in 2004. You can see, it is published in 2004, and you can see among the 15 causes of death in the world, among the top 15, cancer is the second. So you can see how deadly is cancer. First is heart diseases, which are the most, cause the most mortality, killing among people. But cancer is the second, and of course list goes down to different type of diseases. Suppose like cardiovascular diseases, chronic lower respiratory diseases, means lung diseases, accidents, diabetes, Alzheimer, influenza, and nephritis means kidney problems, septicemia means infection, and internal, some people commit suicide, killing themselves, and so on. So you can see cancer as a major cause of the death is the second rank. And you can see here, I'll show you the other aspects. This is the rank of the diseases. This is the cause of the diseases. And then we go to number of the deaths, how many people have died in 2004. And there are other type of percentage of the death, how many percent. And then the last one is death rate. Means, again, this number which we can see here is every 100,000. Suppose 217 people of 100,000, among 100,000 people, usually this is the number that shows the rate of the death. So because of this reason, cancer is one of the major diseases which attracts attention of most of the pharmaceutical companies, as well as a lot of institutions, research institutions include, suppose, my laboratory, which is mainly involved in design and development of new anti-cancer agents. So this is something that's very, very interesting. It is done, it is again another type of statistics in United States and also in Utah. Utah state in United States. Why Utah? Because Utah has the least percentage of cancer in the whole United States. So this one is, Utah is because of this. I'll go for one out of 3 people will develop cancer in their lifetime. 1 in 8 women will develop breast cancer in their lifetime. 1 in 6 men will develop prostate cancer in lifetime. Over 1,400,000 people will be diagnosed with cancer this year. That is 2004 that I talked about. And 550,000 will die from cancer. This is what was the statistics. And considering Utah, approximately 5,600 people will be diagnosed with cancer at the same 2004. Approximately 2,500 people will die from cancer, and overall cancer rates are 15 to 20% below the national average. You can see Utah has the lowest rate of cancer in the whole United States. And lung cancer rate, this is usually affecting both men and women, usually in Utah is less than half of the national average. And it is very, very, very interesting why. The reason for this is, Utah usually they try, smoking in Utah is the least, So the number of smokers in Utah is the least in the whole United States. That's the reason number of lung cancer is the least. 20%, less than national average. Now we'll talk about, what is cancer? Cancer is originated from normal cell. I'll show you later, It grows continuously, usually fast, and do not undergo normal cell death. I talked about this subject at the beginning of my lecture, that normal cell usually has a lifespan, dies, when you go to the life cycle. But cancer cell doesn't die. That's the reason usually you have death from cancer cell. And the last one here, and the last one is lack of normal function. Cancer cell is not like a normal cell, and that is one of the things that it affects badly your body. This is just simply to show how a normal cell and cancer cell usually are growing. This is normal cell. One cell become 2 cells, and again this will be continued. In the meantime, cell will be damaged. There is no repair, and then automatically at this stage, cell will simply suicide, means will be die by itself. There is a mechanism in the cell by the name of apoptosis. This is this mechanism. So it's called programmed cell death. Programmed cell death means cell by itself, kills itself. So when it reaches, suppose 4 days, depending upon the location of the cell in the tissues, usually the lifespan of cells are different, 4 days, 5 days, 10 days, 2 months. But by the time that they reach to that type of time span, usually they kill themselves. So cell will be died. What about cancer cell? Cancer cell, you can see, at the beginning, suppose we look at this, the mutation means change in the biology of the normal cell. So then there is another mutation, and the third mutation, and the fourth mutation, and this is the time that cell will grow crazily, just simply without any control. Cancer cell will grow, and that is one of the major problem you can see is uncontrolled growth of cancer cell while normal cell dies. So when normal cell dies, usually it will be excreted from your body. Here, there are 6 hallmarks of cancer. What is the specifics about cancer cells? First is, it is self-sufficiency in growth signal. There are a lot of signaling pathway, in the body, in any cells, that usually controls the cell cycle. And in this specific case, cancer is completely independent for that. It's self-sufficient. It is insensitive to anti-growth signals. This is the second one. Tissue invasion and metastasis. When cancer cells become more and more, this is called, it reaches to the stage that as soon as it becomes specific size, it will go to the capillary vessels and then go from, suppose, kidney to brain. To move, transfer from one place to other place, it is called metastasis. And so this is one thing that normal cell never does. Limitless replicative potential. It means that it grows as much as it can, There's no death. Sustained angiogenesis. Angiogenesis means formation of blood vessels, So when blood vessel is formed over here, cancer cell can be fed very easily. So when food and everything which is necessary for cancer cell will be provided by these capillaries, and these capillaries are a lot in the cancer cell. And then evading apoptosis. This is one thing that simply it ignores, doesn't go through apoptosis, means cell death by itself. So cancer cell will not die. So there's 6 hallmarks, 6 indication of or representative of cancer cell line which affects our body. We have to keep in mind, these are important notes, when we want to treat a cancer, we have to be, completely sure that we know that the diagnosis of cancer we have done the right diagnosis of the cancer. And that right diagnosis usually needs, microbiology needs us or people who are involved in cancer research to know microbiology of cancer cell. And also, usually you have to use biomarkers and also screen those against the different cancer cell lines in order to understand which type of cancer it is. Means you take the sample and send it to pathologists, and pathologists usually look at that and identify that, okay, this is breast cancer or this is other type of cancer. This is first thing. That main approaches in treating cancer, usually the most effective treatment include these then. Surgery is the best. Surgery is the best, but when is the best? It is the time that cancer is diagnosed in very early stage. So in very early stage, you can remove it. You can remove it by surgery, and there is nothing left.